have write down a metallic disc of radius A. A metallic rod of radius A rotates with angular velocity omega about a vertical axis through a uniform field B pointing up. A circuit is made by connecting one end of a resistor to the axle and the other into a sliding contact which touches the outer edge of the disc. Find the current in the resistor. You can see this problem, the statement of this problem in your book. What the statement is, here the statement is a metallic disc. This is a metallic disc which has a radius A, and this is an axle, and it rotates with angular velocity this, and here these are the magnetic field in this direction. This is being touched to this, and here some resistance and also touches to this. If it rotates, then the current flow in this circuit. So we have to find out the current in this circuit. So how it is possible? So let's see. Here, if I write down here, the speed of a point on a disk at a distance s from the axis is. If there is some, let's suppose there's some distance and this is a radius s, we consider here some distance, some point with distance s. So what will be the velocity of this point? So we can write the velocity v is equal to omega r or s. So we have considered this is s. You may write down also r as well, no problem. Now the source per unit charge. The source, the force per unit charge. What is the unit? The force per unit charge as this is the magnetic force, and actually this is VB, QVB divided by Q. So Q will be cancelled out, and VB and VV also know this is equal to omega S and B with some direction S. What is the EMF? We have to find out first the EMF. The EMF must be equal to, we have to integrate this from 0 to A because this is the radius, from 0 to A, and F magnetic force dot ds. So if we remove the dot product, then we can write down this like 0 to A, and F magnetic force is equal to W as B and ds. And further, this is a simple integration. Omega B will come out from this integral, and 0 to A S ds. So this will be s square divided by 2, and omega b, this is s square divided by 2. By applying the limits, then it will take the form as omega b a square divided by 2. This is EMF. Now we are interested to find out the current I. So how we can find out the current I? Because E is equal to IR. We know about this. So if I have to calculate the current I, then EMF divided by R resistance we can find out, and this EMF I have already calculated. So this will be equal to omega B A square divided by 2R. So this is actually the current that produced in this circuit.